This is a video for 3.4 notes, and this is a section over the product and quotient rules. And remember, product means multiply, quotient means division, and this is when we're taking the derivative of a function that is composed of the product of two functions, okay? So what this theorem says here is that if I have a function f and I'm multiplying it by a function g, then I take the derivative of f, multiply it by g, plus f times the derivative of g, okay? So one way that I would put this, another way to write it, so another way to write it would be let u and v be functions, okay? I tend to use u and v in this case, just because we use f and g so much. I'm going to kind of start using u and v. So let's take a look. If I take the derivative ddx of some function u times some function v, then I get this. I get u times v prime plus v times u prime, okay? And it's the same thing that I've got here, okay? But let's look at an example. Let's say that f of x is equal to, say, I don't know, e to the x times, 4x squared plus 3x, okay? What I'm going to do is I'm going to let this be a function u, okay? And I'm going to let this be a function v, all right? And the way that I write this out is I do this. I let u equal e to the x, and I let v equal 4x squared plus 3x. And what I'm going to do is I have to find a u prime and I have to find a v prime. So I'm going to take the derivative of u, which is just going to be e to the x, easy enough. But then I'm going to take the derivative of v prime, okay? And that's going to give me 8x plus 3, okay, using the power rule. All right. Now, the way that I do this is I take u times v prime, all right, and then I take v times u prime. Now, when I do that, this is kind of how I remember how to do this. I write out what my values are, and the way that I think about it is that I cross multiply and then add them together. Okay, so if I make this symbol here, I cross multiply them, and then if you kind of tilt your head to the left a little bit, you can kind of make out that this is a plus sign. So, if I wanted to write f prime of x, then I get u times v prime. So I'm going to write this, e to the x times 8x plus 3 plus e to the x times 4x squared plus 3x. And so this whole thing that I've got here is my derivative of f, okay? And this is why we need the product rule, okay? We kind of learned that in, another section that if I've got a f of x and it's like, say, x squared plus 1 times, say, 3x plus 2, then what I can do is I can actually multiply this out or FOIL it. Okay, so I would end up getting f of x is equal to, say, 3x cubed plus 3x plus 2x squared, and then plus 2. Okay, and I could find the derivative of this using the power rule, and that's going to give me 9x squared plus, I'm going to reorder this and get 4x plus 3 and then plus 0. Okay, I could use the product rule here. Okay, I could call this my u and call this my v. Okay, and I could, let u equal x squared plus 1, and I could let v equal 3x plus 2, and I could find u prime, which is going to give me 2x, and then v prime, which is going to just give me 3. And I could cross multiply and add them together. And if you simplify it, you'll get the same thing. Go ahead and try and do that if you get some time. But the problem is that if you don't have something that you can multiply out, like this, where you've got e to the x, which is a completely different function, it's an exponential function, times a polynomial, When you have two of these that you can't simplify any further, this you can rewrite and simplify. This you really can't do that, okay? So, um, and so that's where, the product rule really comes in handy, okay? Okay, let's move on to the quotient rule. Okay, and this is when you have the division of two functions. So if I have a function f divided by a function g, then if I take the derivative of that, I get the bottom function g times the derivative of my top function minus the top function times the derivative of the bottom, all divided by the bottom square. Okay, so there's an easier way to do this. Okay, what I'm going to do, there's a little saying that I use, and that saying kind of goes like this. If I take the derivative, with respect to x of some high function divided by a low function. Now, this one's high because it's up top, okay, and this one's low because it's on the bottom, okay. And so I'm going to denote the derivatives. If I take the derivative with respect to x of, say, the high function, then that's going to give me d high. Okay, if I take the derivative with respect to x of the low function, that's going to give me d low. Okay, so here's how I do this. It's a little saying, but if I take the derivative using the quotient rule, the way to remember the quotient rule is I've got the low function times the derivative of the high minus the high function times the derivative of the low all over low times low. Okay, low squared. So if you say this out loud and you say low d high minus high d low over low low, then that's what your derivative is, and that can help you remember it. And so that's how I remember it: low d high minus high d low over low low. All right, and so let's look at an example real quick. Let's just look at something like this. Let's just say I have a function f of x is equal to, say, 3x squared plus 2 divided by x plus 1. Okay, I can't divide anything out here. I can't simplify this. So I have to use the quotient rule. We in the previous section, we were able to simplify this and then take its derivative. But if you can't simplify a rational function, then you have to use the quotient rule. Okay, so I'm just going to go up here. This is my high function. This is my low function. So high is equal to 3x squared plus 2. And then d high is going to be 6x. Let me erase this real quick. All right. Let's go ahead and do the d high. And that's going to be 6x. And then the low is equal to x plus 1. And so d low is equal just to 1. Okay. So if I wanted to find my derivative, f prime of x, okay, I'm going to use low d high. So where's my low function? Okay, it's x plus 1 times the derivative of my high, which is 6x, so times 6x, minus the high, which is the quantity, 3x squared plus 2, times the derivative of the low, which is 1, and then all over low. So it's going to be x plus 1 squared. Okay, if you want to go through it using this method, you can. I'd prefer to do this. All right, this is easy for me to remember. And in fact, there's one of my colleagues remembers it pretty well. I'll have to see if they remember it. But what I want you to do, we could simplify this. I'm not going to do that right now. I'm going to save some time with this. But you may want to multiply all this stuff out, and sometimes things simplify, sometimes they don't. Okay. So let's take a look at another one. Another rule that I have for this section that I want to talk about is the derivative of e to the kx, where k is a constant. Okay, k is a number. Okay, that's a number. So I'm going to treat it like a number. So let's just look at an example here. Let's just say I have a function f of x is equal to e to the 5x. Okay, if I were to take the derivative with respect to x of e to the 5x, okay, then I'm going to get this. I drop down my coefficient, which is this 5, and multiply by e to the 5x. Okay, not a k, it's an x. All right, so pretty standard. Whatever that coefficient is, you bring it down and multiply it out front. Okay, let's do another example. Let's say f of x is equal to e to the negative pi x power. Okay, we got a function like this. Well, if I found its derivative, f prime of x, I'm just going to drop down the negative pi out front, multiply it by the same thing as what I had, e to the negative pi x. That's an x. Sorry, folks. Getting ahead of myself here. All right, and put that x up there. Okay, so just drop down that coefficient up front. All right, so let's take a look at an example. We're going to do problem number 14 two ways. We're going to apply the product rule first and see what we get. And then we're going to multiply everything out and then find its derivative. Okay, so I'm going to do this. I'm going to go ahead and call this my u. I'm going to call this my v. So u is equal to 2x plus 3. V is equal to 5x squared minus 4x. And so if I find my derivative u prime, then that's just going to give me a derivative of 2. Okay. If I find v prime, then I'm going to get 10x minus 4. All right, so if I wanted to use the product rule, I'm going to cross multiply and add them together. So dy dx, okay, which is the same as y prime, these mean the same thing, it's just my derivative, is equal to, let me do 2x plus 3 times 10x minus 4. And then I'm going to add that to 2 times 5x squared minus 4x. Okay, so if we simplified this, let's go ahead and simplify. I'm going to get 20x squared. Okay, and then I'm going to get plus 30x. All right, and then I'm going to get negative 8x. And then minus 12. Okay, and I'm going to distribute this 2, so then I get plus, what is that? 10x squared, and then minus 8x. Okay, so if I go through this, I get y prime is equal to, let's combine our like terms here. I've got 30x squared. I've got negative 8 minus 8, that's negative 16. So negative 16 plus 30, that's going to give me, what is that, 14? So plus 14x, and then minus 12. Okay, so that's my derivative. All right, and it's kind of a painstaking process to do that, to simplify that, if you got a polynomial. But let's do it again, but let's just do it, let's multiply it out first. So I've got y equals 2x plus 3, and then I've got 5x squared minus 4x. Let's go ahead and multiply this out. So I've got y equals 10x cubed. All right. 3 times 5x squared, so give me plus 15x squared. And then I've got 2x times negative 4x, that's minus 8x squared. Okay. And then 3 times negative 4x gives me minus 12x. Okay, I can combine these like terms here. So I've got y is equal to 10x cubed, and this is plus 7x squared, and then minus 12. Do you guys see it? Do you see it yet? All right, if I find my derivative, if I find y prime, then I drop my 3 down, multiply it by 10, so I get 30x squared, and then I get plus 14x. Oh, and this is an x. And then I get minus 12. Folks, I get the same thing. Okay, so if you can multiply it out, you know, and it's a little bit simpler, this is a little bit less stressful, I think, than doing the product rule. Sometimes the product rule is absolutely necessary, but if you've got two, if you've got two of these polynomials, I'd go ahead and just multiply them together. So it's the same thing, all right? So either way, it doesn't matter to me, okay? All right, let's take a look at number 20 and number 30, all right? And so when I look here, I've got t squared minus 1, and then I've got, so you can actually simplify this. Let's go ahead and just do the, you can simplify this and then take the derivative. Let's just use my, the quotient rule. So this is my high function. This is my low function. All right. So, sorry, high and then low. So if high is equal to t squared minus 1, that means that the derivative of my high function is just going to be 2t. All right. If I take my low function, that's going to give me t squared plus t minus 2, and then my d low, derivative of my low, is 2t plus 1. Okay. So what I'm going to do is use low d high minus high d low over low low to find the derivative of f. So f prime of t, okay, I got my low function, so I've got t squared plus t minus 2 times the derivative of my high, so times 2t, okay, minus the high, which is t squared minus 1 times the derivative of the low, which is 2t plus 1, and then all over low squared. Okay, so I get t squared plus t minus 2, and I'm going to square that. So what you will want to simplify this. Okay, I'm not going to do that on the video because we don't really have time, but I want you to try that on your own and see what you get. You also might want to try factoring this, seeing what divides out, and then doing the quotient rule. Okay, that might make it a lot simpler. Okay, but I wanted to just show you the rule and show you how you apply it. Okay, I'm going to do 30. 30 is a little bit more complicated. 30, you can't factor anything out. You can't simplify it. So this is my high function. This is my low function. So my high function is x squared plus 3 times e to the x. My low function is 2e to the x minus x. So d high is equal to 2x, and then the derivative of 3 times e to the x is just 3e to the x, okay? Take the derivative of my low function, 2e to the x, it's just going to give me 2e to the x, and then minus x, the derivative of that is just minus 1, okay? So if I wanted to find y prime here, okay, I'm going to take my low function, so 2e to the x minus x times the derivative of my high, which is 2x plus 3e to the x, minus, you know what, I'm going to move all this down. I love technology. Okay, okay, so I got low d high minus high, so x squared plus 3e to the x times the derivative of the low, so that's 2e to the x minus 1, all over low squared. So I'm going to take my low function, which was 2e to the x minus x, and square it. Okay? You would want to simplify this. This is a painstaking process. I don't have the time for it on the video. But rule of thumb is if whatever the answer is in the back of the book, you want to turn this into that answer in the back of the book. Okay? I've got a couple more problems for you. Let's go ahead and find this one. Now, let me rewrite this. This is W is equal to R times e to the negative R, okay? And so this is the product rule, folks. This is a function. R is a function times e to the negative R. This is another function. I can't simplify this. I have to use a product rule. So I've got U is equal to R, and I've got V is equal to e to the negative R, not x. Okay, so I want to find U prime, and the derivative of R is just 1. The derivative of V prime, okay, and I've got e to the negative R. So this has a coefficient in front of it. So I have to apply that rule that we learned, and I have to write negative e to the negative R power, okay? And so I end up getting this. I'm going to do U times V prime, so, and then V times U prime, cross multiply and add. So then W prime is equal to R times negative E, this looks terrible, W prime equals R times negative E to the negative R plus 1 times E to the negative R, okay? Now, we could also use the quotient rule here, okay? If I wanted to rewrite this, okay, if I want to rewrite W, I could write that as R divided by e to the r, okay, e to the negative r. I can move that down into my denominator. So now I've got a high function, and I have a low function, and I can do the quotient rule. So let me write this out. High, low, d high, d low. So my high function is r. The derivative of my high function is just 1. Low, okay, that's e to the r. And then d low is just e to the r. Okay, so if I wanted to find w prime, all right, I would end up getting this. I'd get low d high, so e to the r times 1 minus my high function r times e to the r all over low squared, e to the r squared. Okay, that quantity squared. So the question is, are these two things the same thing? Well, let me go ahead and simplify this one. And so here's what I've got. Let me do this. I've got, I'm going to rewrite, I'll do the top part first. W prime is equal to, I have a common e to the r in my numerator. So I could factor out an e to the r, and I'm left with 1 minus r, and that's all over, and let me rewrite this as e to the r times e to the r, okay? And so I have an e to the r that divides out, and so my derivative is just going to be 1 minus r over e to the r, all right? Now let's see if I can get that same thing over here, all right? And I'm going to rewrite this, I'm going to rewrite it like this. I'm going to move around my negative sign a little bit, and so I'm going to get negative r times e to the negative r plus 1 times e to the negative r. And I can factor out a common e to the negative r. So w prime is going to be, I can factor out e to, negative. W prime is going to give me e to the negative r, and I'm going to multiply that by negative r plus 1. Okay, now since I have a negative exponent here, I can put that in my denominator. And so w prime is equal to e to the r on the bottom, and I've got negative r plus 1. That's the same thing as 1 minus r. All right, so I end up getting the same thing. So there are times when you can, it doesn't matter what you do, it's whatever you're comfortable with, okay? And so that's all I've got for the 3.4 notes. There's a lot going on here. There's a lot of algebra involved. As long as you know your rules and you know how to use them, then it can be fairly easy. So I hope you enjoyed this, and we'll see you soon.